Hey, imagine if we could build nuclear power plants that are safer, cheaper, and much quicker to construct. Well, that's exactly what small modular reactors, or SMRs, are promising. Let's explore what SMRs are and how they are changing the game in energy production and why many nations are betting big on them. A traditional nuclear reactor is massive, producing around 1000 megawatts, typically taking 8 to 10 years to build and costing billions of dollars. They require vast areas and extensive infrastructure, making them challenging to construct. Small modular reactors, on the other hand, represent a fundamentally different approach. These reactors are much smaller, usually generating between 50 and 300 megawatts. The size is likely that of a shipping container or a small industrial building. Their compact size allows them to be manufactured almost entirely in factories, using standardized modular parts differently than traditional nuclear plants, which needs to be built on site. Once built, these modules are transported to the installation site, ready to be quickly assembled. This modular process drastically reduces construction timelines, usually to just 2 to 3 years, and significantly lowers initial investment costs. Unlike traditional reactors, SMRs utilize passive safety systems. This means they rely on gravity and convection to cool themselves automatically, without requiring external power or pumps like traditional nuclear plants. This passive cooling dramatically reduces the risk of accidents, providing a much safer operation, even in worst-case scenarios like total power loss. Moreover, SMRs are scalable. Do you need more power? Simply add another module. This flexibility makes them ideal for various applications, from powering small remote communities and industrial sites to supplementing larger power grids. Major nations see SMRs as crucial to achieving clean energy targets. The United States, for example, approved NuScale's design in 2025, aiming to power remote areas, military bases, and data centers. The United Kingdom has backed Rolls-Royce SMRs, with plans to have the first unit operational by 2030. China already operates an SMR plant at Shidao Bay, and Russia powers remote Arctic communities with floating reactors. Small modular reactors offer these nations an opportunity to diversify their energy sources, reduce carbon emissions, and enhance energy security without the massive investment and lengthy construction times of traditional nuclear plants. Like every innovative technology, SMRs come with their own set of advantages and challenges. On the advantages side, one of the biggest is that SMRs are rapid in the construction. Traditional nuclear plants often take almost a decade to build, causing significant delays and budget overruns. SMRs, being largely factory-built and modular, can be completed in some few years, significantly reducing financial risk and uncertainty. Another major advantage is their lower initial cost. Building a traditional large reactor involves huge investments, often billions of dollars, limiting the number of countries and companies that can afford them. SMRs, however, require substantially less capital, typically hundreds of millions instead of billions, making nuclear power accessible to more nations and regions, including developing countries. Another advantage is that SMRs are equipped with passive safety systems, meaning that even if all power is lost, they can cool down naturally without external intervention. This reduces the likelihood of accidents. Additionally, SMRs offer flexibility and scalability. Instead of building a huge plant all at once, you can add smaller modules incrementally as energy demands increase. This modular approach allows utilities and communities to adapt their power infrastructure in a cost-effective, manageable way. SMRs also excel in versatility, providing energy for diverse needs, from remote towns and industrial hubs to urban grids and specialized facilities like data centers or desalination plants. However, SMRs also face significant challenges. For instance, their initial cost per unit of electricity is higher until mass production scales up, which requires large-scale demand and investment. Bureaucracy and regulations present another challenge, as SMRs designs typically need new regulatory framework or updated approval processes, potentially slowing their widespread adoption. Waste management remains another important concern. While SMRs produce smaller volumes of nuclear waste compared to traditional reactors, secure and sustainable disposal solutions are still essential and require careful planning. Finally, public perception around nuclear power remains cautious. Overcoming skepticism and clearly communicating is vital for their broader acceptance. Despite the advantages of SMRs, traditional reactors still hold important benefits. For instance, large-scale reactors excel in delivering substantial amounts of continuous power, meeting high energy demands efficiently from a single location. Their established supply chains, long operating history, and mature regulatory frameworks offer a sense of reliability. If you enjoyed this video, don't forget to like, subscribe, and tell us your thoughts about SMRs in the comments. Thanks for watching, goodbye and see you soon!